Okay, so what is probability? Probability is a number that reflects the chance that an event will occur. And when we are not sure about an event, we speak in terms of probability. So, say when a doctor is unsure about a patient's diagnosis, he might say something like this: based on your symptoms, there is a 70% chance that you have cold, but we will run some test to confirm. Right? So, when you are unsure about something, you will speak in terms of probability. And how do you calculate probability? Number of favorable outcomes by total number of outcomes, right? Then we move on to discuss the properties of probability. The first property of probability is that sum of probabilities of mutually exclusive and exhaustive events equals 1. This is something we'll discuss in next slide with examples. The probability of an event is between 0 and 1. And if the probability of an event is 0, then it is an impossible event. So example is stock market will increase today is an impossible event. Why is it an impossible event? Because today is Sunday, market is closed, so its probability is 0. If the probability of an event is 1, then it's a guaranteed event. Now example of a guaranteed event: sun will rise tomorrow, right? Sun will rise tomorrow is a guaranteed event. Its probability is 1. Okay, and the last property or probability is that a probability of an event cannot be negative. It is either 0 or greater than 0. So these are the properties of probabilities, right? Okay, now let's move on to the next slide, where we'll discuss this first property with examples. Okay, so the first property was that the sum of probabilities of mutually exclusive and exhaustive events is equal to 1. So before discussing this property, we need to discuss what are mutually exclusive events and what are exhaustive events. Now, mutually exclusive events are events that cannot occur together at the same time. They cannot occur together at the same time. Such events which cannot occur together at the same time are mutually exclusive. And what are exhaustive? Exhaustive means that you've covered all possible outcomes, right? So let's study this property with the help of an example. Now, when you toss a coin once, when you flip a coin once, there are two possible outcomes: head and tail. Are these mutually exclusive? Ask yourself, guys. Are these outcomes mutually exclusive? Yes, they are. If you get a head, you can't get a tail, and vice versa. So these events are mutually exclusive. And are these events exhaustive? Okay, so ask yourself, can there be any other outcome apart from these two? No. These events, these outcomes are collectively exhaustive. There is no possible third outcome, right? So these outcomes are mutually exclusive and exhaustive. Okay, so what is the probability of getting a head? 1 by 2. What is the probability of getting a tail? 1 by 2. Now if you sum these probabilities, you get 1. If you add up these, you get 1. So the sum of probabilities of mutually exclusive and exhaustive events equals 1, right? Let's move on to another example. Guys, what are the possible outcomes when you roll a dice? It could be 1, 2, 3, 4, 5 or 6, and their respective probabilities are 1 by 6, right? Now these outcomes too are mutually exclusive. If you get a 1, you can't get a 2, so on and so forth. Just let me allow someone. Okay, so these outcomes are mutually exclusive, right? If you get a 1, you can't get a 2, and so on. Are these events exhaustive? Can you get any other outcome apart from these? Guys, please tell me. Can you get any other outcome apart from these?
No, sir.
No. So these events are exhaustive. So they are mutually exclusive and exhaustive. And if you add up the probabilities of these outcomes, you will get 1. So if you add, all these 1 by 6, you will get 1. So 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6 equals 1. So this is the basic property of probability, that if you add the probability of mutually exclusive and exhaustive events, you'll get you'll get 1. Okay, moving on to the next slide. Okay, now we are trying to define events, and basically there are three types of events. Okay, the first is your mutually exclusive, the second is your independent events are unrelated events, and lastly dependent events, right? Okay, so let's start off with mutually exclusive. Before that, guys, do you have any doubts up till now? Any doubts, guys, up till now? Yes or no, please tell me.
It's clear, sir.
Okay, so
Clear.
two events, we will start off with mutually exclusive events. Now two events A and B are mutually exclusive if they cannot occur together at the same time. If they cannot occur together at the same time. Guys, the idea behind telling you all this is that when I start solving questions, right, your foundations would be clear, right? Your foundations would be very clear when I start solving questions. And mind you, when I'll solve questions, I'll not be using any formulas, right? I'll not be using any formula when I'll be solving questions. So keep that in mind. Okay, so going back to my PPT. Okay, so let's discuss mutually exclusive events. Now, two events A and B are mutually exclusive if they cannot occur together at the same time. Okay, so emphasis is on at the same time, right? Please note this. Emphasis is on at the same time. Okay, so if you flip a coin once, can we get a head and tail at the same time, guys? Can we get a head and tail at the same time?
No, sir.
No.
No, sir.
So this is a mutually exclusive event. If we roll a dice once, can we get 1 and 2 at the same time? No. This too is a mutually exclusive event. Let's now understand what independent events are. Independent events are basically unrelated events. And two events A and B are independent. Okay, guys, so people are joining in late. That's why there are a lot of interruptions. Okay. So two events A and B are independent if the outcome of event A does not affect the probability of event B. This is very important. If the outcome of the first event does not affect the outcome of the okay, if the outcome of the oh guys, so people are joining in late. Okay. So two events A and B are independent if the outcome of the first event does not affect the probability of the second event. Now examples would be, consider flipping a coin twice. Getting a head on the first flip does not affect the probability of getting a head on the second flip. So this is an independent event. Now flipping a coin and rolling a dice. Right guys, these two are basically unrelated. right? Flipping a coin and rolling a dice are unrelated things. So the outcome of the first event would not affect the probability of the other. So this too is an independent event, right? Now, lastly, discussing what are dependent events. Now, two events A and B are dependent if the outcome of one affects the probability of the other, right? The outcome of one affects the probability of the other. And remember, dependent events are related events, right? So, example would be robbing a bank and going to jail, right? So, if you rob a bank, the probability of going to jail increases. So the outcome of the first event affects the probability of the other, right? Okay, guys. Any doubts with respect to this slide? Should I move on? Should I move on to the next slide? Any doubts, anyone?
No, sir, all clear.
Clear.
Now, guys, we are going to discuss the three types of probability. Okay, so let me see the chat box. Okay,
Sir, maybe someone joined late, so maybe you can't understand.
okay. So unconditional probability. Now we are going to discuss the three types of probability. So the three types of probability that we are going to discuss are unconditional, conditional, and joint. These are the three types of probabilities that we are going to discuss. Okay. So first is my unconditional probability. Now, as the name suggests, it is the probability that has no conditions attached with it. It has no strings attached, right? So it's the probability with no strings attached. And unconditional probability is the probability that is unaffected by what happened in the past or what may happen in the future, right? So this is the probability that is not affected by what happened in the past or what may happen in the future. And unconditional probability of an event A is written as P bracket open, A bracket close, right? So this is how you denote unconditional probability, right? So unconditional probability of an event B would be written as P bracket open, B bracket close. Unconditional probability of an event C would be written like this, right? So this is how you denote unconditional probabilities. Okay, let's do some examples, guys. If we flip a coin, what is the probability of getting a head? It is 1 by 2. Will this probability get affected by what happened in the past or what may happen in the future? Guys, will this be affected? No,
No, sir.
it's never going to get affected by whatever might have happened in the past or whatever happens in the future. This is not going to get affected. So this is an unconditional probability, right? Probability of getting ahead, which is 1 by 2, is an unconditional probability. It's not going to get affected by what happened in the past or what might happen in the future. Okay. Now, if we roll a dice, what is the probability of getting a 1? It is 1 by 6. Will this probability get affected by what happened in the past or what might happen in the future? No. Again, the answer is the same. So, this too is an unconditional probability, right? So, probability of getting a 1 when you roll a dice is 1 by 6, and this too is an unconditional probability. Right, guys? Are we good? Should I move forward? I think I'm
Yes,
good.
sir.
Okay, now what is my conditional probability? Now, unconditional probability had no conditions attached to it. Conditional probability, as the name suggests, has conditions attached to it, and it is affected by what happened in the past. Your conditional probability is affected by what happened in the past, right? Okay. And what is your conditional probability? It's the probability of an event B occurring given that A has already occurred. Now I'm going to give you examples of conditional probability later on, but it's the probability of an event B occurring given that another event A has already occurred. And this is how we write conditional probabilities, right? You'll read this as probability of event B occurring given event A has already occurred. So guys, when I write P A given B, what am I trying to say, right? How will you read this particular notation? Please tell me. How will you read this particular notation? Can someone tell me?
Probability of B
Probability
given
of
probability of A.
occurring given that B has already occurred.
Yes, so we'll read this as probability of event A occurring given B has already occurred, right? So this is how you read your conditional probabilities. This is how you will read these notations, right? Now, examples of conditional probability is something that I'm going to tell you in the forthcoming slides. Okay, so let's move on to my next slide. Okay, last point here, dependent events have conditional probabilities. This is something we are going to see in the forthcoming slides. Okay, and the last is joint probability. Now, joint probability is the probability of two events occurring together at the same point in time. Now, the emphasis here is on same point in time. What is the probability of two events occurring together, right? So, it's written as P A and B. You read this as P A and B, or it can also be written as P A intersection B, right? This is something that we must have learnt in school, right? We must have seen in school PA intersection B. That is nothing but your joint probability. And joint probability of two events A and B is denoted as, so your joint probability, which is PA and B, is equal to unconditional probability of A, right? This is the unconditional probability of A into conditional probability of B given A has occurred, right? Now this is basically the conditional probability of B given A has occurred, right? This is the conditional probability of B given A has occurred. This is how you calculate joint probabilities. Now I'm going to have a uh, very intuitive discussion on this in the forthcoming slides, right? Okay. Now guys, we are going to discuss unconditional, conditional and joint probability of mutually exclusive events, right? Okay, so two events A and B are mutually exclusive. What does this mean, guys? So let me remove these slides for once, and guys, please tell me what are the um what is the conditional probability of mutually exclusive events? What is the conditional probability of mutually exclusive events? So see, if A and B are mutually exclusive, if A and B are mutually exclusive, that means that they cannot occur together at the same time. So what is the probability of B given A has occurred? Please tell me. A and B cannot occur together at the same
Zero.
time.
Zero.
0, right? Why? Because if A has occurred, B cannot occur, right? Why? Because A and B are mutually exclusive. They cannot occur together at the same time, right? So if A and B are mutually exclusive, then their conditional probability is going to be 0. Why? Because if A has occurred, B cannot occur, right? So their conditional probability is 0. Conditional probability of mutually exclusive events is 0. And what is the joint probability of A and B occurring together? Well, again, A and B are mutually exclusive. Their joint probability is going to be 0 because they are mutually exclusive. They cannot occur together at the same point in time, right? So their joint probabilities are also 0. So please keep this in mind, guys. Conditional and joint probabilities of mutually exclusive events is 0. This is something very important, right? And I'm trying to break down probabilities on the basis of events, right? This is something that has not been taught to us in school and maybe in our graduation level, but I'm trying to break down probabilities on the basis of events. Okay, guys, any problems with this slide? Should I move on to the next slide, please? Should I move on to the next slide? Yes or no?
Yes, sir.
Okay. Now, what is the conditional and joint probability of dependent events? Now, this is something very interesting. Okay. So, guys, later this is something very interesting. We'll discuss this with the help of example. Okay. Now, what is the joint probability of getting two aces continuously from a deck of 52 cards, right? So, let event A be getting an ace in the first draw and event be getting an ace in the second draw, right? So, first we need to understand whether these events are independent or dependent. So, guys, what do you think? Um, are these events independent or are these events dependent? So guys, these events are dependent. Why? Because the outcome of the first event is going to affect the probability of the second. Now how? Please understand, guys. If the first card is an ace, then there are only 3 aces left in the remaining 51 cards. So if the first card is an ace, the probability that the second card would be an ace is 3 by 51, right? If the first card is an ace, then the probability that the second card is an ace would be 3 by 51, right? However, if the first card is not an ace, say it's a queen, then there are 4 aces left in the remaining 51 cards. So if the first card is not an ace, then the probability that the second card would be an ace is 4 by 51. So guys, we can see that the probability of the second card being an ace depends upon whether the first card was an ace or not. Or we can say that these are dependent events. The outcome of the first event is affecting the probability of the second event. Guys, is this example clear to you? Do you have any doubts? Please ask me here. Guys, can you see how the outcome of the first event is affecting the probability of the second? If the first card is an ace, then if the first card was an ace, then after the first draw, there would be only 3 aces left in the remaining 51 cards, right? So the probability of drawing a second ace would be 3 by 51. However, if the first card is not an ace, say it's some other card, then there are still 4 aces left in the remaining 51 cards. So the probability that the second card would be an ace would be 4 by 51, right? So the outcome of the first event is affecting the probability of the second event. The probability that the second card is an ace would depend upon whether the first was an ace or not, right? So these are dependent. Guys, are we good here? Any doubts, please? Yes or no? Do you have any confusions with respect to this slide, guys? Yes or no? Please tell me.
All good, sir.
All of you all good? If you have any doubts, I can explain it here. Okay, so I think there are no doubts. I'm moving forward to the next slide. Okay, so what is the joint probability of getting two aces? Okay, so probability that the first card is an ace is the unconditional probability of drawing an ace, which is 4 by 52. And you know, however, probability that the second card is an ace is a conditional probability. It depends upon whether the first card was an ace or not, right? So probability that the second card is an ace given the first card was an ace is 3 by 51. So guys, this is your event B, this is your event A, right? So we can write this as probability of B given A has occurred, right? We can write this as probability of B given A has occurred, right? And this probability, this conditional probability is going to be 3 by 51. Why? Because if the first card is an ace, there are only 3 aces left in the remaining 51 cards. So that is why probability of B given A is 3 by 51, right? So now you have to calculate the joint probability, where you will just multiply the unconditional probability of drawing an ace into the conditional probability, which is 3 by 51. Guys, are we good here? Any doubts, please? Yes or no, please tell me.
Can you repeat it again? I got confused.
Okay, so what's the probability that the first card is an ace? Please answer. What is the probability that the first card is an ace? There are 4
4
aces
by
in
50.
52 cards. So the probability that the first card is an ace is 4 by 52. And this 4 by 52 is nothing but the unconditional probability of drawing an ace, right? This is the unconditional probability. Now, what is the probability that the second card would be an ace, given that the first was an ace? If the first was an ace,
3
then
over
you will have
51.
only 3 cards left, 3 aces left in the remaining 51 cards, right? If the first was an ace, then the probability that the second would be an ace is 3 by 51, because if the first is an ace, then naturally there are only 3 aces left in the remaining 51 cards. So the probability or the joint probability of getting 2 aces is 4 by 52 into 3 by 51. Are we good here, guys? Any doubts now? Any doubts now, or do you still have confusion?
No doubts, no doubts.
So guys, this is your formula of calculating joint probability, which is unconditional probability of event A into conditional probability of B, right? So we have tried to derive the formula here rather than just giving you the formula. I've tried to derive the formula, right? So joint probability of dependent event is equal to unconditional probability of event A into conditional probability of B given A, right? Guys, please tell me if you have any doubts here. Yes or no? I want a yes or a no from everyone here.
No, sir.
Anmol, Victor.
Good, sir.
No.
Okay,
Good, sir.
good, very good. Okay, okay, okay. And guys, you can basically rewrite this equation, right? You can rewrite this equation to get the conditional probability of B given A, right? You can rewrite this equation to get the conditional probability of B given A. Okay, so basically your joint probability of A and B was probability of A into conditional probability of B given A. So now what is the conditional probability of B given A? You just rewrite this equation, right? Probability of B given A is you take this to the left hand side of the equation, so it will become probability of joint probability of A and B by unconditional probability of A, right? So you'll just rewrite this equation to get the conditional probability of dependent event. Okay, so this is the broad idea, guys. We are very close to solving questions, right? This webinar would get over sooner than we thought, right? Okay, last, guys, conditional and joint probability of independent events. Okay, guys, let event A be today being a Sunday, event B being getting ahead on a single flip of a coin, right? So the unconditional probability of event A is 1 by 7 and unconditional probability of event B is 1 by 2. Now these are independent events, guys. Naturally, tossing a coin and today being a Sunday has no relation with each other. They are unrelated. Okay. Now since they are independent, since they are unrelated, tell me what is the conditional probability of getting ahead given today is Sunday. So this is your event B, this is your event A. So tell me what is the conditional probability of B given A, guys?
1/2.
It's going to be 1 by 2 only, right? Why? Because probability of a getting ahead is not going to get affected by what day of the week it is. If you were to flip a coin on a Monday or a Tuesday instead, the probability of a getting ahead would still be the same, right? So the conditional probability of getting ahead given today is Sunday is is 1 by 2, and 1 by 2 is what? 1 by 2 is nothing but the unconditional probability of B, right? Okay, guys, is this idea clear? Any doubts here? Any doubts, please? Yes or no?
No doubt, I am understanding it now.
Okay, so guys, we had said, so we arrived to the conclusion that the conditional probability of independent events is going to be the unconditional probability of is going to be their unconditional probability. So in the last slide we said that joint probability of A and B was probability of A into probability of B given A. But if A and B are independent, then probability of B given A is going to be the unconditional probability of B. So I can write this as probability of B. So now this equation would be, or the joint probability of independent events is going to be PA into PB. Now this is the test of independence. If two events are independent, then their joint probabilities are going to be the product of their unconditional probabilities, right, guys? So this is maybe uh, this discussion has been slightly heavy, but I'm trying to build a more uh, a more intuitive logic by giving you examples, right? So guys, now we'll be solving questions, right? We'll be solving a question using the tree approach that we see here, and we are going to cover Bayes theorem as well, and we'll cover Bayes theorem without even you realizing that I have covered the Bayes theorem. So any doubts up till now, guys? Do we have any doubts? Please say a yes or a no. If you have doubts, you can say yes. If you have
No,
no
sir.
doubts, say no.
No, sir.
Okay. Now let's start solving questions. Right. This is, um, you know, this was the point of discussing all the slides that I discussed in the past. Right. Okay. Now, guys, we know companies pay dividends to their shareholders, and companies pay dividends when they are in profits, right? And dividends vary with profits. Now tell me, guys, payment of dividends are dependent upon profits, or are profits dependent upon dividends? Please tell me. Are profits dependent on dividends, or dividends
Prof-
dependent?
Profit dependence on even dividend.
Dividend depends upon profit. See, your dividends would depend upon your profit, right? If the company has profits, then it may pay dividends. However, if it does not have profits, then it won't pay dividends, right? So whether company pays dividends or not, it is dependent upon profits, right? So your dividends depend upon your profits, right? Your dividends would depend upon your profits. Okay, guys. Now, if the company is in profits, then chances of paying dividend increases, and if the company is in losses, the chances of paying dividend decreases. Now let's say the unconditional probability of profit is 70% and the unconditional probability of loss is 30%, right? Okay, now if there are profits, probability of paying dividends increase. Say probability of paying dividends when company has profits is 70%. Now this is a conditional probability, guys. Please note that this is a conditional probability, right? Probability of dividends given profits, right? How will you read this? Please tell me, how will you read this? How will you read this, please? How will you read this number?
Prob-
So this number would be,
pro-
this number is, how will you read this number? So probability of
Probability of
giving
paying
dividends when the
dividends.
company is making profits is,
Pro- Probability of paying dividend given the company is making profit.
yes, the probability of paying dividends when the company is making profits is 70%, right? Okay. The probability that the company will pay dividend given it's making profits is 70%, right? This is a conditional probability and this is how you will read this. Okay. And let's move on to this second leg. Okay, what is the probability of not paying dividends given profits? Now this is going to be 1 minus 70, that is 30%. Now why is it going to be 30? Because guys, these events are, this event and this event are
Mutually
mutually
exclusive.
exclusive and exhaustive, and their sum should equal 1, right? Sum of their probabilities should equal 1, right? This 70 plus 30 should equal 1. Now why are they mutually exclusive and exhaustive? Say if you have profits, either you will pay dividends or you won't. There cannot be any other possibility, right? That is why these two events, this first event here and this second event here, is mutually exclusive and exhaustive, and since they are mutually exclusive and exhaustive, sum of their probabilities should equal 1. Guys, are we good? Any doubts up till now? Any doubts, please, guys? Yes or no? Yes or no, please tell me. Okay, I think you have
No,
some
no.
doubts.
Clear, sir.
Now let's move on to the next leg. See guys, if there is a loss, then probability of paying dividend reduces, right? Naturally, if the company is giving a loss, it won't pay dividends, right? Or chances of paying dividends would reduce. So probability of paying dividends given a loss, say probability of paying dividends given a loss is 10%, right? Or chances that the company would pay a dividend given it is experiencing a loss is 10%. So this too is your conditional probability, right? And naturally guys, if this is 10, then this is going to be 90, right? And what is this? This is the probability that the company would not pay dividends given that it is experiencing a loss, right? So if this is 10, this is going to be 90, Logic is the same. These two events are mutually exclusive and exhaustive. The sum of their probabilities should equal 1. Okay. So guys, you can see we are using the tree approach. The first branch of the tree is your unconditional. The second branch is your conditional. Now the third is joint, right? Third is joint, right? So I had told you that your joint probability is unconditional into conditional, right? Joint probability is equal to unconditional into conditional, right? So now you just multiply these probabilities, right? Just multiply these probabilities to get your joint probabilities. So the joint probability of getting, joint probability that the company pays dividends when it is making profits is 49. How do you get it? 70 into 70 is 49, right? Probability that the company, joint probability of company not paying dividends when it is in profits is 21. How do you get this? 70 into 30, 21, right? Now joint probability of company paying dividends when it is making a loss is 3%. How do you get this? 30 into 10, 3. And joint probability of company not paying dividends given it is making a loss is 27. How do you get this? 3 plus 90, 27. Guys, are we good here? Any doubts up till now? Guys, any doubts?
Good, sir.
Anyone? Okay, now you add up the probabilities in node 1, node 2, node 3 and node 4. How much do you get? Add up all these probabilities. Add 49, 21, 3 and 27. Tell me how much do you get? Please tell me how much do you get?
100.
100. Okay. Now the examiner may ask you what is the unconditional probability of paying dividends, right? So guys, out of these 100 cases, right? Out of these 100 cases, in how many cases the company is paying dividends? Please identify. Out of these 4 cases, in how many cases the company is paying dividend? Okay, the
One.
company is paying dividend at node 1 and at node 3, right? Company is paying dividend at node 1 and node 3, right? So if you add up the probabilities at node 1 and node 3, you get the unconditional probability of paying dividends. Guys, are we good? So unconditional probability of paying dividends is 49 plus 3, 52. Any doubts here, guys? Is this simple? Have we used any formula? Guys, have we used any formula? Yes or no? Please tell me.
No.
No problem.
And what is the probability of not paying dividends? Okay, so out of these 100 cases, in how many cases the company is not paying dividends? The company is not paying dividends at node 2 and node 4. So add up the probabilities at node 2 and node 4. So at node 2, the probability is 21. At node 4, the probability is 27. So 27 plus 21 is 48. So the unconditional probability of not paying dividends is 48. Okay. Guys, any doubts here, please? Is any doubts? Yes or no?
No, sir, but I have a question.
Uh-huh.
In second branch, we in conditional probability, will those values 70%, 30%, 10%, 90%, will it be given in questions
Yes,
or we
yes,
have a
yes,
right?
yes, yes, yes. This would be given in the question.
Okay,
Don't
okay,
worry
sir.
about it.
Thank you.
Don't worry. Those would be given in questions. If it's not given, we won't be able to calculate, right? So later on, I have a question here. We'll do this question. You guys will do this question. I won't, right? Uh, in the first problem, I'm just trying to illustrate. Now, guys, I hope you have no doubts. Now, guys, calculate conditional probabilities. Once we've calculated the unconditional probabilities, we'll calculate the conditional probabilities, right? So now, guys, say company has paid dividends. I'm giving you this information that the company has paid dividends. Now we need to calculate what is the probability that the company has made profits. Now listen to the question very carefully. Given that the company has paid dividends, given that the company has paid dividends, what is the probability that the company made profits? We need to calculate this. How will you calculate this? Very simple. You don't have to use any formula. You no need to mug up anything. Okay, guys. First tell me, in how many cases has the company paid dividends? Out of these 100 cases, in how many cases the company has paid dividends? Please answer. Out of these 100 cases, in how many cases the company has paid dividends?
Two cases.
52 cases,
52.
right? And out of these 52 cases, in how many cases the company made profits?
49.
49. Look at note 1, right? 49. So out of these 52 cases, company made profits in 49 cases. So your conditional probability that the company made profits given it has paid dividends is 49 by 52, which is 94. Guys, any doubts with this? Any doubts, anyone? Yes or no? Please tell me.
No, sir.
Now calculate this one. What is the probability that the company made a loss given that it has paid dividends? Right? Again, this is going to be really simple. Company paid dividends in 52 cases, right? Out of these 52 cases, in how many cases the company was giving a loss? 3 cases, right? 3 cases. So the conditional probability uh, that the company made a loss given it had paid dividends is 3 by 52, which is 6%. Guys, any doubts with this? Anyone's having any doubts here? Yes or no? Please tell me. Any doubts? Yes or no? Will you be able to solve questions on your own now? Okay. Please tell me, will you be able to solve questions on your own now?
Yes, sir.
So try this out. Now the question is, given that given that the company has not paid dividends, not paid dividends, what is the probability that the company made a profit? Given that the company has not paid dividends, what is the probability that it made a profit? Okay, so you please solve this. Take a minute or two to solve this.
Is it 21 by 48?
21 by
Very
48.
good. Very good. Right. So how will you reason this out? Okay. The company has not paid dividends in 48 cases. Right. Out of these 48 cases, in how many cases the company was making profits? In 21 cases. Right.
21.
Very simple. It's very simple. So the conditional probability that the company made profits given that it has not paid dividends is 21 by 40. And guys, what is the probability that the company made a loss given that it had not paid dividends? Please solve this as well.
27 by 48.
27 by 48.
Very good. So guys, all these are Bayes theorem questions, right? All this are Bayes theorem, right? And how does Bayes theorem look like? This. So you don't need to look at any formulas. You don't need not know the definition of what Bayes theorem is. And Bayes theorem is something that scares students. It's like a nightmare to students. Bayes theorem is kind of a nightmare. But the approach that we are taking, bypasses all those formulas, right? We just need logical reasoning to solve questions, right? But the idea of telling you all these was that if I had not told you all that, if I had not shared these things, you won't be able to have a basic foundation on probability. So, guys, are we good? Yes or no? Please. Are we good? Anyone's having any doubts? Daniel, Sumit, Zishan, Victor, Mayank, Anmol, rest of
Good,
you,
sir.
Saurabh, Sumit, Sayyad,
Clear, sir.
Good, sir.
Shivam. Okay. Okay. So, guys, given this, just solve this question and you'll be good for the day. Right? You'll be good for the day. Where did the okay? Okay. So, guys, just do this question. Uh, guys, I take level 1, level 2, and level 3 classes thrice a week. If if anyone's interested in joining my course, you are most welcome. The fees is also very nominal. It's not that much. In Indian rupees, level 1 fees is around 6,000 and level 2 fees is around 9,000. Uh, and that's about it, guys. And we'll be having such sessions on every Sunday. We'll be covering quants every Sunday for the next 2 months, right? So if you wish to join my sessions every Sunday, you are free to join. There's no issues. And I take L1 and L2, L3 classes continuously. I mean regularly. So if you anyone wants to join my course, you are free to do that as well. Okay. So guys, let's solve this question. How will you solve this? Please tell me. So first we'll make these branches. First branch is unconditional, second branch is conditional, third is joint, right? Okay, so there is a 60% probability that the economy will outperform. And there is a 40% chance that the economy will underperform. Okay. Now guys, please remember if a sentence starts with an if, please remember this. In your question, if the sentence starts with if, then it's a conditional probability. It's a clear cut way. It's a short way of identifying a conditional probability. The sentence starting with an if tells us that it's a conditional probability, right? Or if the sentence starts with a given, it's a conditional probability. So these are the two methods in which you can identify your conditional probability, and these are short methods. So if the economy outperforms, there is a 70% probability that the stock would go up, right? So this is your conditional probability. And how do you write this conditional probability? Probability of stock going up given economy is outperforming, right? Probability of stock going up given the economy is outperforming. And then the sentence says that there is a 30% probability that the stock will go down, right? So this is your 30%. And how will you write this? Probability of stock going down given economy has outperformed, right? Now let's move on to our next leg. Okay, there is a 40% probability that the economy will underperform. This is my unconditional. I've already written this, right? Next we'll make the next leg of branches. Okay, now it's saying question is saying that if the economy underperforms, so you see another if. Whenever you see an if, it's a conditional probability, right? So if it does, there is a 20% probability that the stock will increase, right? So we write this as probability of stock increasing given economy underperform is 20%. And lastly, we see that if the economy is underperforming, there is an 80% probability that the stock will fall. So we write this as probability of stock falling given economy underperforming is 80. So guys, now we have our unconditional probabilities here and we have our conditional here. We multiply the two, we'll get joint probabilities, right? So 1, 2, let's name these nodes 3, 4. Now start multiplying. 60 plus 70, 60 into 70, 42. 60 into 30, 18. Right? Into, not plus, into. 60 into 70, 42. 60 into 30, 18. 40 into 28, 40 into 80, 32. Right, guys? Now add these up. How much do you get?
Sir, how can we get this 42%? This joint probability?
60 into 70. How much is it?
Okay.
So I'm now doing this fast because in the exam you won't have so much.
100%.
Thank you, sir.
This would add up to 100%. Probability at node 1 plus probability at node 2 plus probability at node 3 plus probability at node 4 would add up to 100%. Now guys, what is the unconditional probability of stock going up?
100%.
What is the unconditional probability of stock going up? Now please see, out of these 100
50%.
cases, in how many cases the stock is going up?
Two cases, sir.
In the
Two
first
cases,
node
1 and
and
2.
in the third node, right? The stock is going up in the first node and in the third
So
node. So if you add up the probabilities of the first and the third node, you'll get the unconditional probability of stock going up, which is
50,
42 plus 8, 50%. And what is the probability of stock going down? Right now, out of these 100 cases,
50.
stock is going down at node 2 and node 4. So if we add up the
2 and
probabilities of node 2 and node 4, we'll get the unconditional probability of stock price going down, right? Okay, now guys, next question is, what is the probability that the economy outperformed given the stock price increased? What is the probability that this economy outperformed given that the stock price increased? How will you solve this? Okay, in how many cases has the stock outperformed? The stock has outperformed in 50 cases. Now, out of these 50 cases, in how many cases the economy outperformed? In how many cases the stock price
42.
rose? 50 cases, right? And out of these 50 cases, in how many cases the economy outperformed? 42
42.
cases. So,
42.
conditional probability that conditional probability of the economy outperforming given that the stock price increased is 42 by 50, that is 84%. Again, this is a Bayes theorem question, right? They'll address this here as an Bayes theorem question, but we are not using any formulas. Now, what is the probability of the economy underperforming given that the stock price has increased? Okay, so the stock price has increased in 50 cases. Out of these 50 cases, in how many cases the economy has underperformed? Bolo? Guys, please tell me. The economy has, the stock
8 by
price has
8.
increased in 50 cases. Out of these 50 cases, in how many cases the economy has underperformed? 8 cases, right?
8%.
8.
Here, the economy has underperformed 8 cases. So 8 by 50 is your 16. Now solve these guys. What is the probability of the economy outperforming given that the stock price has gone down? And what is the probability of the economy underperforming given that the stock price has gone down? Please do this. And we'll end our session here.
18 by 50 and 32 by 50.
Very good. Right. The stock has gone down
18
in
by 50 and 32 by 50.
50 cases. And out of these
18 by
50
50.
cases, in 18 cases, the economy has outperformed. Right. So 18 by 50 is how much? 30, 30, 36, 36, no? 18 by 50 is 36. Am I right?
Yes, sir, 36%.
And the next probability that we need to calculate is, give me the probability of the
64%.
economy underperforming given that the stock price has gone down. The stock price has gone down in 50 cases. Out of these 50 cases, the economy has underperformed in
30,
32 cases.
32, 64%.
So this is how you solve any question. You don't need to look at what Bayes theorem is saying. You don't need to look at anything, guys. any question on probability, whether you are appearing for CFA L1 or your FRM Part 1 or whatever course you are doing on finance, you need not look at formulas while calculating probabilities. So I hope things are crystal clear. I hope you guys have no doubts, right? And
Yeah, sorry. Can I see